Hello and welcome to our Tips and Techniques videos. I'm Mark Biasotti and we are currently in our advanced modeling episodes. And over the next 30 minutes or so, we'll be exploring how you can increase your skills using some of SolidWorks' more advanced features so that you can be more productive and create higher quality models. So whether you're a seasoned SolidWorks user or a beginner, we think that you'll learn something new in this series. For your convenience, we've listed the topics in the YouTube description that we'll be covering in today's episode, along with a timestamp for each topic in the video. Feel free to skip ahead to any tip or point you want to learn more about. This series is being brought to you by Spanner Product Development, a product development company dedicated to creating positive impact in the world, merging innovation, sustainability, and responsibility to bring meaningful experiences to life for over hundreds of clients. If you want to learn more about what Spanner has to offer, stop by our website at spannerpd.com or email us at hello@spannerpd.com. Now let's get started with this episode of our Advanced Modeling episodes.
Well, welcome to our SolidWorks Advanced Tips and Techniques series. This is episode 7, and this is working with curves, a continuation. And for the next 30 minutes or so, I'm going to cover these topics to somewhat expand on what we've talked about in our last episode, talking about the different curve types. I'm going to go more into the anatomy of Thru-Point and style splines to explain their controls a bit better. And then, as I mentioned in our first episode of working with curves, I'm going to talk about conics, how you can use those in place of Thru-Point in some cases. And then this one is an important one that a lot of you have probably had trouble with, but I wanted to show you some of the techniques that I use to overcome over-constraints with splines and how I constrain them, especially in 3D. I think it is worth going a little bit more into continuity and C2 and C3 matching when creating splines to geometry that is associated to it. I'm going to talk a bit about face curves, and this is where we'll look at this feature and then how you can use face curves to simplify those curves to use them again in your features. And then I'll just explore a little bit of spline on surface and what that has to offer, and try to do all this in the next 30 minutes. We'll see how we do. So let's get into SolidWorks and talk more about these spline types, Thru-Point and style splines. So let's spend a little bit of time talking about our two major spline types of creation in 2D and 3D. And we'll just stay in 2D for right now to explain them a little bit more. So this model that I created quite a while ago still is a good platform for understanding curves or splines. And if we roll back to the base sketch and unhide that, and then go to, I believe it's right plane, we can start to take a look at how we would create the base geometry or base curves for this product. In the right plane, let's just start here. It's important that we put a base sketch down that shows this profile, this under profile, this digital tire gauge. So I'll just start with a Thru-Point spline and I'm going to ignore the small radius right here and maybe start here. And when I create Thru-Point splines, I'm basically looking for moments of inflection. And this radius, this reference radius, is important for me. So I'm basically, when I lay down and I rough it out, I'm looking to those areas where inflection happens. And that gives me a good starting point for the spline. Okay, so here we have our basic spline. And the next thing that you usually want to do is either constrain these to existing geometry, fix them, and define their angle. So that's what I'm doing here with some construction geometry. And we'll do the same here at the end. We'll move this down. Let's just fix it for the time being. And then we'll use construction as a quick way of defining the angle, the start angle. If I could just pick that, so there we go. And if we anchor that, then we can easily kind of change our beginning angle and magnitude. So now it's up to me to go in and start moving around the interim points to get the best match that I can. I hold off on actually changing magnitude until the very last moment because I want to keep my continuity good, and as I explained in the last curve video. So you can get pretty close by just moving the points, but then there comes a time where I really have to start changing the magnitude and angles of these. So doing that a little bit more, and then before I even attempt to change magnitude here, I'll just move things around a bit more to make them closer to what I want to do. And it looks like now I have to go in and change magnitude here. So again, I'm going to hold down my Alt key to do a symmetrical magnitude change. And then I will probably then resort to changing just a single magnitude here. Okay, and probably take this point and put it towards the middle of this kind of ball radius, and then bring this point down to match a little bit better. So you can see, as I talked about in one of my earlier videos, that advanced modeling takes a lot more time and care because there's a lot of interpretation that occurs. So again, I'm trying to avoid any magnitude change or direction change. So you can get pretty close without even changing the magnitudes of the interim vertices. And once you get to this point, you probably want to turn on your curvature. Don't do it too early. You want to get it close. And then let's bring the scale down on that. So it's something that we can study. Also, the default color for the combs is a color I don't think is very noticeable. So I go into my system colors and I look for the first temporary graphics shaded, and that's this one. I think the default color I think it's yellow, and so I make it something that's a bit more pronounced, especially on a white background. And then if you want the actual edge of the comb, that's a setting, I believe, under Sketch. So show curve comb bounding curve. Those are helpful to have on. So now you can see we've gotten pretty close. You can see here we have a little bit of a bobble, and that's because I changed the magnitude of just one handle. But that's probably as good as we're going to get it. Now, just a little explanation. So as a review, this control changes the angle. This control changes the magnitude. and the dot at the end does both at the same time. If you want them to be symmetrically changed, if you hold down your Alt key and pull on the little ball at the end, you can see that they're changing both on both sides of the interim vertice. Okay, so that's how they work. It takes some getting used to, and they work pretty well. But again, like I said, I wouldn't be satisfied with this. So there's a great feature that came in 2.17, I believe, and that is the ability to take this and convert this Thru-Point to a style spline. And so that's what we're going to do. So if you right-click it, if you look in your right mouse button menu here, you get Convert to Style. So I'm going to click on that, go through the menus, and now I've converted that to a style spline. And you can see it keeps it as close as it can. Remember, it's a different curve type. It's Bezier versus B-spline. So it has to do a certain amount of conversion. You're going to lose some of that following the underlying sketch picture. But now you can get much smoother continuity. And you can also simplify. And I'll talk about this a little bit more in a following episode of the video. Maybe I'll get it in on this one. It turns out you can't simplify that. I think it would be only if it's a converted entity or imported curve. But in any case, you can simplify it by starting to delete these cage points and then move these around. So you can see that the curvature is much better already. So we're just going to eliminate some of this. And again, that is really a process of simplifying. And we'll get this to be more of a round shape by moving our cage around. And when possible, I'm actually simplifying it, because now that it's a style, I have all the internal curvature quality that I want, and I don't need many of those points. So it looks like probably I should add one right here. So I'm going to do that. I'm going to just right click over the cage and then insert a control vertice. So when you do this, you're going to see that sometimes you get a red X. That means that it can't place it. You can't place that degree in that particular point. So in that case, you just move it to where you do. So there's the red that you can't, and then if you click on it, you can. So now I'm going to move this up, and you can see with more degree, I have more control of the spline itself to shape it to what I want. So I'm not going to belabor this too much, because I could tweak on this all day. But you can see how I'm using these points. And so that is our style spline. And if we modify the scale a little bit more, you see it gets to be a lot smoother curvature throughout the entire spline. And the added benefit of style spline is then I can start to dimension those points with regular smart dimensioning. So here I'm just doing some X and Y dimensioning from my endpoints. And as I move to the proper position, I can do that. I find that oftentimes what I'll do is put in some reference geometry. If the spline is trying to be more primitive in its shape in some areas, so like in this trigger area, I'll go ahead and put in some additional geometry for construction. Let me just fix it for the time being, and then use that so that I can either match or constrain to get that more to my liking. So I think, anyway, you can see you can dimension it. I won't belabor it too much. Yes, you can convert back to a spline, but at this point I don't want to. So that's a little bit more on the anatomy of style and Thru-Point spline. So let's move on to our next example. And I believe that would be talking about conics. So conics are important because they can, in certain instances, make more robust models than splines can, and essentially do the same thing. So here we have this very simple example of this box, and currently it's just a box with a side radius, a flat on top, and an arc in the sketch that represents the corner. And you can see that I've mirrored it by 2. So really back at its base feature, it's this. So we're going to go into this. And the industrial designers asked for something that's a little bit more curve continuous on a corner. So what I'm going to do is, I'm just going to create a conic and replace it with this sketch element. So conics are right here. And if they aren't there, you can customize them into your command manager. And the way that conics work is you pick the beginning and end point. You pick the XY matching point. I'm not sure how to describe that. You don't have to do that, but it's a nice little helper. And then the last thing you do is set the row value. And the row value is, think of it as kind of the radius value of the conic. And there we have our base conic. Let me just replace that for right now with this current one. So I'm going to click here, go to my replace sketch entity feature, and you can see it's selected with this conic. And so now that's important because then, you know, my geometry will update. All the children's geometry will update. Let's turn on our relationships. And you can see there really isn't a relationship there yet. So I just take this and make it coincident and make this coincident with that side arc. And then I'll work on the conics. Now, you can actually constrain the row value point. I think what I'll do first, though, is let me put a dimension in here to hold our quasi-radius value. And then we want to do it from here, and we actually want these to be equal to each other, as if it were radius. Okay, and getting back to the conic, you can actually stretch this value out. Using this point, you can constrain this point. So if you wanted to do something like this, where you do have a radius there, but you want it to be C2, you can actually constrain this with a dimension. Let's say that it is something like 20. And don't worry about that. That's an error in the solver. It does that when you have a coincident point on arc and a conic. Not sure why it does it. Should probably submit an SR to get that fixed. But in any case, we can constrain that with construction geometry. And so now you've got something that is mimicking a 29.89 radius, but also is C2. Let's not do that for the time being. Let's just put in a hard value. So I'm going to get rid of this construction. And just, if you click down on the conic, then you can dimension the row value. And I find that 0.475 is close to round, but keeping with the draft and the C2 nature of what you do through a through spline. And that's probably what I didn't mention, is that when we first entered this exercise, most would probably just say, okay, it has to be C2, let's just do a spline. So we do a spline here, and then we make tangency, but then we have to kind of mess with and control and dimension this spline to make sure that things are symmetrical, that it's at the right value. And that's where a conic has more value, because really you've constrained the endpoints to be tangent. You have one value to actually grow or shrink, depending on how much curvature you want into that corner. So now that we have that, I'll rebuild, and that's interesting that it didn't pick up the fillet. It should have. Let's find out why. That's probably another bug too. That shouldn't do that. Could it be that I didn't make that tangent? Let's undo and find out. So maybe that was my fault. Yeah, sure enough. So that should be tangent. Okay. And again, I think it's because of these values that it's over constraining. Let's try that. There we go. Okay. I'm not sure why that happened either. I'll have to do a little bit more investigative work, but I think now that you rebuild, yeah, you'll get the radius. And then if we turn on zebra, we can take a look at how nice the light flows over that. So it's not actual C2. That's why I call it quasi C2, because conics aren't truly C2, but they do behave or affect the model in the same way, in that you're drawing out the curvature to a higher degree. And if I were to show the zebras on these, I'm sorry, the curvature on these, well, that's a line, so it doesn't have any curvature. But in any case, we're getting something that's closer to matching. And in some cases, like if the plastic is textured, there's really an adequate solution to doing that. So that's Conics. I highly encourage you to take a look at them and use them. So moving on, let's talk about a really important topic, and that is when creating splines in 3D or in 2D and constraints. Because oftentimes you probably have seen where you've created especially 3D curves or splines, and they can be easily over-constrained. So let's try to reproduce that problem. I'm going to create a spline from here to here. Let's go ahead and make it C2 on both ends. And of course, it probably behaves correctly here. But if we want to start to affect the shape of that, you can see that there's a point of inflection there that I really don't like. I don't want that to occur. So I'm going to try to tweak on it a little bit more, and I might even go in and create an interim vertice point. So let's do that. Probably what we should do here is convert this to a style spline. So let's go ahead and do that. And we'll have a bit more control over this to keep it always inflecting and not dropping down. And I think that looks pretty good, actually. We should always check the constraints to see if they hold. So that's one curve for doing a bridge surface here with this bridge curve. So let's do a 3D version of that. So we're going to go into 3D. Oops, that's not actually what I wanted. I want to just go straight into 3D sketch. And then let's do a Thru-Point spline. And of course, remember my 2D triad. Let's tab it so that we're going in the direction from our left to right. We'll grab this edge and we'll go over here. Okay, so basic spline. Now, when it comes time to constrain this to be tangent or curvature to these opposing surfaces, I often find that it's much more robust. Let's get into the right view here. To do a face curvature or a face tangency. And I'll show you what I mean by that. So let's kind of get it into close to the shape we want. And then we could just click on the curve and on the face and apply tangency. But as you can see, things kind of go wonkers there. And unless it's constrained, it's going to try to move to a position that it really wants to do that. So let's undo that. And instead of that, I'm going to use what's called a face constraint. And the way a face constraint works is if you hold down your control key, click on the spline itself, then on the edge of that face, and then the face itself. And you see that now you get a face tangency here. Okay? I'm going to do the same to the other end. Again, hold down control, click on the spline, on the edge of the face, and then the face itself. Okay. And do face tangent. So what that means is if you look at it in the top view, it'll hold tangency and it'll slide along that entire face because it's not dependent on the tangency at the point of where you clicked, but it includes the whole face tangency. This can be really helpful to doing more complex curves that aren't just kind of bridging right across from each other. And I'll show you why. So if I'm kind of approximating the tangency in this axis, and then I start to slide it, you know, you can also have a lot of degree of freedom here. Okay, so it's a very useful way to constrain. I think if we didn't have this point here, let's eliminate it, and let's bring down the magnitude. You see how as we slide it, it maintains its direction. That's really robust when it comes to parametric change. So we're going to put it right about here. Okay. And you can see that my magnitudes are really forced. So another thing you can do with splines that's often useful is to relax them. So you have this button down here to relax and also reset handles. And between these buttons, they can get you out of a lot of situations where if it's over constrained or not the shape you want, you have those available to you in the property manager. Okay, let's do a third one. And let's this time again do a 3D sketch spline Thru-Point. And let's pick some points here. Let's just eliminate the interim one. And then pick these two edges and apply C2. Now, something to be noted that I mentioned in the last episode, that in SolidWorks 2020 you have G3 continuity for sketch splines and other geometry. It doesn't apply to 3D yet, so you can only do it in a 2D sketch, unfortunately. Hopefully it'll come in the near future. So it seems to be behaving pretty well here. If we were to put in that spline again, with multiple points. Again, remember my 2D triad, I need to toggle it in this direction. Let's throw that curve in there. Do C2. And we've got it fairly well constrained, but not the shape that I really want. So it's at this point where you can often over-constrain when you start to tweak on these through-point splines. And they get rather hard to control. And that's where you probably want to invoke the sketch triad to move things. Now, because of its constraint, doing X and Y control doesn't work. If that doesn't work, grab this guy, which is kind of X or YZ in a plane, and you get a little bit more control that way. If you want to move the triad to another selection, you can do that. And again, I'm going to move it to something that I want, more like that. And so that's where it becomes pretty powerful to work in 3D. As long as you have the control to do it. So yeah, I can expound on this and tweak on it all day, probably. For right now, this looks pretty good. Okay. So we've got some geometry. See, this one's pretty wonky. That is because of this point here. And again, let's use this control. And we can see this even in more clarity if we bring up the curvature comb. So that's not very desirable there. So the way to fix that would be to, in this view, start to tweak on this until we don't get any inflections, or try to simplify. It might help to hide the other sketches just so that you can see better. I purposely did this example because of there's a large change in radius of this surface to this one. And this is a difficult situation to try to match. Okay. That's looking better. But in 3D, of course, it's not straight. So this is where you want to kind of straighten it out a little bit more, like that. Okay. So let's turn back on our sketches, and we have something then. We can create a boundary surface from this edge to this edge, and then through these curves. So we're going to pick that, and that guy. Okay, and then apply curvature here. Now the reason it warns me there is because I didn't, on one of these curves I probably didn't apply curve continuous. And so it gives you a warning. It'll still create the surface, but it gives you the warning. And I'm sure I could go into one of those curves and find it. If we go back to our property manager and show these, we can go into this guy, and we see that we have C2 here, we have C2 here, but here we don't. So we need to apply there, and then using our face constraint, do the same here. And let's just check our last curve there. That has C2, that has C2. So now, now you shouldn't have a problem, and you can see it visually if you turn, if you have real view on, or if you have your zebra on. Zebra I like to use not the default zebra, but the plain sky, because it gives me just one line and then I can evaluate my curvature. That looks pretty good. Another area that's worth spending just a little bit of time on is how to work with these Thru-Point splines or style splines to get better curvature matching. And what I mean by that is, let's take this simple example. We have some base geometry here. We're going to create a Thru-Point spline from these 2 points, more like a bridge curve. We're going to apply tangency at this point. And then let's take all of this and let's apply our curvature. So you can see that we have tangency, but we don't have equal curvature where these elements meet. Now, you can take, just with a tangent constraint, you can start to tweak on these handles to apply something that matches using the comb. And so that's what I'm doing here. And you can see that can become pretty difficult with just a 2-point spline. If we add an additional interim point, then we'll get the ability to do that with a little bit more control. But you can see that now we are kind of in the weeds, as you would say, as we start to play with our magnitude. And it almost becomes impossible to do. Now, fortunately, with SolidWorks, if you have a 2-point spline and you have created a C2 continuity on either end, you can do what's called degree raising, and here it's done it automatically. So it's actually raised a degree so that you have curvature matching at both ends. You could get this to be a little bit better with a style spline. Again, in SolidWorks 2020, you can, in 2D, put in G3 matching. So if we take that and apply G3 to it, then we get an even better curvature result on that corner. Again, you're not going to get the control that you might expect with a through-point spline. You get a little bit of it, but you can see it can easily over-constrain too. And when you get this kind of situation again, first try to relax the spline and then reset all the handles. In this example, it doesn't really work. And this is why I probably would have, in real life, done this with a style spline. Because with style spline, you can degree raise it. And we're going to do that right now. Let's just convert this to a style spline. And we can degree raise it. And we need to do that actually by inserting some control points here. But you can see with more control points, there's more that you have to manage. So that's kind of the downside of making splines too complex or with too much control. So here we've made a really tight corner, but it still maintains a good continuity through that corner. Okay, I wanted to mention that. I thought it was worth talking about a bit, depending on what version you have of SolidWorks. You might not have 2020 yet or the G3 capability, and here's a way that you can do it. So one other face type that I want to quickly mention this episode, and I'll try to do it as quickly as I can, we're running out of time here, is face curves. And face curves, if you go to Tools, Sketch Tools, Face Curves, and pick on the face, you get these curves that are laid down on the actual face the model or surface. And usually people are using these for a diagnostic purposes, because then you can actually invoke, the curvature and see what's happening at that individual point in the face. By the way, if you don't want individual 3D sketch curves, because that's what it's doing, is populating your feature manager with individual curves, you can instead of doing that, you can first invoke a 3D sketch, pick the face, and then pick the face curves. Let's bring it down to just one curve and two curves in this direction. And so now you can see that you just have one 3D sketch with multiple face curves in there. So although most people use these as diagnostic, you can use them as modeling features too. So the idea here is that we're going to take this 3D sketch, go into finding all the constraints that are external. Let's just do all in Sketch, and delete all the on-edge constraints. Okay. Then we're going to take this, and because it doesn't have any dependency on the model now, we can reorder it. Let's just reorder it up here. And the reason I'm doing that is because now we want, let's just delete that guy. We now want this to be used as we roll into our boundary surface. And before we do that though, let's roll up to it before that's created. And so now that we deleted all the on-edge constraints, we can actually go in and make other constraints. Let's delete these face curves that we created. And then let's just apply some constraints to this edge and to this edge. Do our face constraint. And you can see it's a generic spline by the way it's highlighted here. If you want to convert that, you can just convert it to a spline. And now you have it holding as closely it can to that generic spline. If you want to, now you can simplify this spline. So by right-clicking on it, simplifying, and then bringing down the number of interim points. So here I'm going to, by default, take and simplify it in half. So I'm going to smooth that. I can go in even more if I want. But now you can see I have half the points. And now I can actually use this as a full-fledged spline. And furthermore, if I roll forward into my boundary surface, I can include it into my curves. And so now I've modified my model with that curve that was one time a face curve. So let's find out what we have left to talk about. I think what we have left to talk about is spline on surface. So spline on surface is a special type of through-point spline. And let me just turn off my zebra here. And spline on surface is a 3D sketch. It has to be, because it's going to assume that you want to follow off a 3D face or surface. So spline on surface, basically, where you start, it picks that surface. And you notice how it's toggling, because right now it has a decision to make which side it's going to go to. So this one is the one I'm going to go to. I'm going to highlight that, and then I'm going to start to create my spline on surface. And if you rotate in TD, in 3D, excuse me, you can see how it's held at all points, spline on surface. It's a useful spline type. I find that oftentimes it'll fail when parent geometry is changed, because it seems to be pretty susceptible to change. Let's just make this a little more normalized. But one thing that's very nice about it is that this 3D sketch spline can split this face. Even though it's not drawn on a 2D plane, it does lie on this face. And so if you invoke your split and use it as the split for this face, it should work. Yeah, there you go. So there's a split face using a spline on surface. So I think that concludes it for this episode and gives you a good basis for using SolidWorks splines or curves. And as we go forward, we'll be seeing these a lot more as we go into advanced modeling and starting to use some of the surface or advanced modeling features.
Thanks for tuning in to today's episode. We hope what you've learned has been informative and can help you to better use some of SolidWorks' advanced features. You'll see in the YouTube description a link to example models used in today's video. Feel free to download it, and you can explore these techniques at your own leisure. Also, we'd love to hear from you, so consider emailing me at the address you see here on the screen. If you need help on your design project or just want to know more about us, stop by our website at spannerpd.com or email us at hello@spannerpd.com. Take care, and I'll see you in the next episode.